In this video, we're going to walk through a realistic end-to-end scenario for securely sharing data between two organizations using Azure. This is a pattern you see all the time in the real world. One organization produces data. Another organization needs to consume it, and that data needs to move across organizational boundaries on a regular schedule. On the surface, this sounds simple, but in practice, secure file sharing between organizations comes with a lot of expectations. It's not just about getting the file from point A to point B. Organizations need to know who sent the data, when it was received, whether the process actually ran, and what happened to the data after it arrived. Because when questions come up later, we think it worked, usually isn't good enough. This is where security, governance, and auditability start to matter. So in this walkthrough, I'm going to show you how to build a secure file sharing pipeline in Azure, end-to-end. Not just secure transfer, but secure transfer with traceability and evidence built in from day one. By the end of the video, you'll have a working pipeline and a clear audit trail across the entire process. Before we jump into the build, let's quickly frame the architecture we're about to put together. At a high level, this solution has four main parts. First, we use an SFTP-enabled Azure storage account to handle secure file exchange. SFTP stands for Secure File Transfer Protocol. It's a method of transferring files over an encrypted SSH connection, using key-based authentication rather than passwords. That means data is encrypted in transit, access is tightly controlled, and credentials aren't being shared in plain text. This makes SFTP a very common choice in government and enterprise-to-enterprise integrations where security requirements are strict. In our setup, the SFTP storage account simulates an external organization securely dropping files for us to consume, with access scoped tightly to only what's required. Next, we ingest the data into an Azure SQL database. We separate raw data from curated data, and we handle cleaning and transformation using stored procedures inside the database itself. That keeps the processing logic close to the data and easier to govern. Then we bring in Azure Data Factory, which acts as the control unit. ADF orchestrates the entire ETL process, including file discovery, data ingestion, transformation, and execution tracking. Finally, we enable end-to-end auditing across all layers. Pipeline runs, activity execution, and database access are all logged and queryable, so the pipeline isn't just automated, it's observable, traceable, and defensible. Let's start with the scenario we're simulating. An external organization needs to send us data securely on a regular basis. They drop files into an SFTP location. We automatically pick those files up, ingest them into a database, clean and transform the data, and store it in a final table for reporting or downstream use. No manual steps. And just as importantly, every step along the way is logged. While this demo uses SFTP, the same design principles apply to other sharing patterns as well. APIs, secure blob storage in another tenant, scheduled drops from third-party vendors, different transport mechanisms, same security and governance mindset. Here we are in Azure. The first thing I do is create a resource group. Think of a resource group as a logical container in Azure. It's basically a way to group related resources so they're managed together. Everything for this demo lives inside this one resource group. That makes things easier to manage while we're building. And when we're done, it also makes cleanup simple. I can remove the entire environment in one go, without hunting down individual resources later. Next, I create a storage account. In Azure, a storage account is a core service used to store data, like files, blobs, queues, or tables. In this case, we're using it to store files and expose them securely via SFTP. Inside the storage account, I create a container. You can think of a container as a top-level folder. Within that container, I create a subfolder where the external organization will upload their files. To make SFTP work, I create a local user. This user gets very specific permissions: read access and list access, scoped only to the container they actually need. Nothing more than that. Once the user is created, I generate an SSH key. This key is what gets shared with the external organization. No passwords involved, just key-based access. Before moving on, I want to make sure everything actually works, so I test the setup myself using WinSCP. Azure provides the private key in .pem format, and WinSCP doesn't support that directly, so I convert it to .ppk using PuTTyGen. Once that's done, I create a new SFTP connection in WinSCP. I point it to the storage account endpoint, attach the private key, and connect. I can see the remote folder. I can download the files, so the SFTP setup is working exactly as expected. Now let's set up the database where the data will land. I create an Azure SQL database. During setup, I define the admin credentials and add my client IP address to the firewall rules so I can connect from my machine. Once connected, I do a quick sanity check to make sure everything is accessible. Then I create the tables we need, a raw staging table for the ingested data, a final table for the cleaned and transformed data, and a stored procedure that handles the transformation logic and inserts the results into the final table. The final puzzle piece in this setup is Azure Data Factory, or ADF. This is the control unit that orchestrates the entire ETL pipeline. It doesn't store data itself. Instead, it coordinates how data moves, what runs when, and records what actually happened. So the first thing I do is create the Data Factory resource. Once it's ready, I launch the Data Factory Studio. Now, before I even think about pipelines, I stop and deal with connectivity. Because at the end of the day, a pipeline that can't talk to anything is kind of useless. This is where linked services come in. A linked service is basically Data Factory's way of saying, here's how I securely connect to another system. It handles authentication and connection details for us, so we're not embedding credentials all over our pipeline logic. In this setup, we need two of them. One linked service connects to the SFTP-enabled storage account. This is our source system. It's where an external organization drops files for us on a regular basis. The second linked service connects to our Azure SQL database. That's the destination where the data will eventually be stored and worked with. With those connections sorted, I create a brand new pipeline. At this point, it's empty, just a blank canvas, but now it actually has meaning. Data Factory knows how to connect to the systems we care about. With connectivity and the pipeline scaffold in place, I shift focus to datasets. Datasets don't actually move data. Instead, they describe it. They tell Data Factory where the data lives and what shape it comes in. On the source side, the first dataset represents the SFTP folder. This dataset points to the source directories on the SFTP server that contain incoming files. You can think of it as a logical view of the folders we're monitoring, rather than the files themselves. Next, we create a dataset that represents the files inside those folders. This one works at the individual file level. Later in the pipeline, we'll loop through every file discovered in the SFTP folder dataset, and each file that gets picked up and processed is described by this dataset. On the destination side, we define a SQL dataset that points to a staging table in the database. This table is intentionally boring. It's just a landing zone. Data arrives here first, exactly as it was received, before we apply any transformations or business rules. That separation is really important for traceability and auditing later on. Now that linked services, the pipeline scaffold, and datasets are all in place, we finally move on to the pipeline logic. The first activity I add is a set variable activity. This is where we generate a batch ID for the run. A batch ID is a unique identifier for a single execution of the pipeline. It becomes really important later because it lets us tie together everything that happens in that run, which files were processed, when the load happened, and how records ended up in the database. Next, we add a get metadata activity. This activity retrieves metadata from the source folder, specifically the list of files available for processing. Once we have that list, we use a for each activity to iterate through it. For each file, the pipeline maps the data to a predefined schema and loads it into the staging table in SQL. After all files have been ingested into staging, the pipeline executes a stored procedure. This stored procedure lives in the database and handles the cleaning, transformation, and loading of data into the final table. Before running everything end-to-end, I test the pipeline up to the copy step. This is deliberate. It lets me confirm that extraction and staging are working correctly before any transformation logic runs. The pipeline executes successfully. I query the staging table, and the data is exactly where I expect it to be. With that confirmed, I run the entire pipeline. This time, the data flows all the way through. Files are ingested into staging. Transformation and cleaning logic runs. The final table is populated. I run some test queries on the final table, and everything looks correct. I also confirm that the staging table has been cleaned up as expected. Now that the pipeline works functionally, the final step is making sure it meets data governance and data sharing requirements. In other words, we need to be able to audit the entire process. Auditing means we can answer questions like, what ran, when it ran, what data was processed, and who accessed it. There are two options here in Azure: log analytics or a storage account. The first gives us fast visibility and powerful querying. The second gives us cheaper long-term storage for raw logs. We can then enable auditing across all processes in our solution, starting from the pipeline and ending at the destination SQL server. For this walkthrough, I start with log analytics. So I create a log analytics workspace. By default, logs are retained for 30 days, but that can be adjusted depending on requirements. Once the workspace is ready, I enable diagnostic logging for Azure Data Factory. I select all logs and metrics and set the destination to the log analytics workspace. Next, I enable auditing for SQL. This includes both the SQL Server and the SQL database itself, with log analytics set as the destination. With auditing enabled, we test it. First, I trigger the pipeline again. We expect the pipeline run details to be logged. Once the pipeline finishes, I run a few SQL queries manually. Those actions should also be captured. Now comes the moment of truth. I open the Log Analytics workspace. I can browse log tables that capture Data Factory pipeline runs and SQL activity logs. I can also run custom queries. whether it succeeded or failed, and how long it took. I can drill down into activity-level details and answer questions like, did the stored procedure actually run for this batch? On the SQL side, I can see exact timestamps for when customer data was truncated and refreshed, which SQL principal executed those actions, and whether they succeeded. I can also view a high-level access summary showing which identities access the database and how often. This is extremely useful for spotting unexpected accounts or unusual activity. The second auditing option is using a storage account as the log destination. This option is cheaper, but it's more manual and harder to interpret. To set this up, I first create a dedicated storage account just for logs. For this account, I configure lifecycle rules, for example, automatically deleting log data after 7 days. Once the storage account is ready, I configure Azure Data Factory, SQL Server, and the SQL database to send their logs to this storage account instead of log analytics. To test it, I trigger another pipeline run and execute some SQL queries. Then I navigate to the log folders in the storage account. The logs are stored as files with a .xl extension. I download those files and run a PowerShell script to convert them into CSV format. From there, I can inspect the audit data manually. So both auditing approaches work. Log analytics gives you fast visibility and powerful querying. Storage-based logging gives you lower cost and long-term retention at the expense of convenience. The key takeaway is that auditing is not an afterthought. It's deliberately built into the pipeline, so the entire data sharing process is observable, traceable, and defensible. If we take a step back, what you've just seen isn't really about file transfer at all. It's about building a data sharing flow that works in the real world, where security, accountability, and trust actually matter. Yes, data moves from one system to another, but it does so through a pipeline that's deliberate, controlled, and transparent from end to end. We start with a secure handoff. That data lands in a staging area where it's contained and predictable. From there, it's cleaned and shaped in a governed way before ending up in final tables that teams can confidently use. What really sets this pattern apart is visibility. Every run leaves a footprint. Every step can be traced. So when someone asks what happened, when it happened, or who was involved, you're not scrambling for answers or relying on gut feel. You can point to facts. This walkthrough used SFTP, but that choice is flexible. You could just as easily plug in APIs, blob-based exchanges, or third-party feeds. The mechanics might change, but the thinking doesn't. Design for secure access. Be intentional about how data flows. And always assume you'll need to explain and defend the outcome.